Hello, today we'll be looking at simple concentration calculations and we'll be looking at the concentrations of solutions and how to work them out. So, first of all, to start off with, what is a solution? Okay, a solution forms, so solute, dissolves, in a solvent. And this will give us a solution. Okay, so for example, solute. We have salt, we dissolve it in the solvent, which is water, and then we have a solution of salt and water, so we can't see the salt anymore. Now, if we could still see the salt would be a precipitant. However, the salt dissolves in the solvent, forming a solution. Okay, so the concentration of a solution is a measure of how crowded the solute particles are. Okay, so the more concentrated the solution, so the more concentrated, the more particles. The less concentrated the solution, the less particles. Okay, pretty simple. Now, let's move on to see how to calculate concentrations. One thing we'll have to remember for this is the equation. Okay, and also the units that are used in this equation. So, to work out concentration, and the units of concentration are grams per decimeter cubed, which can also be written as grams per decimeter. Okay, this is the same. Concentration equals to mass of solute, and the unit for this is grams, divided by volume in decimeters cubed. Volumes can only be in decimeters cubed, no centimeters cubed, or let's say milliliters. We only use decimeters cubed if the question has the volume in centimeters cubed, or if it has it in milliliters, we have to convert it into decimeters cubed. Now let's have a look at an example using this equation. So the example is 8 grams of sodium hydroxide is dissolved in 2 decimeter cubed of water. Okay, calculate the concentration of sodium hydroxide solution formed. Now, what do we have? Let's have a look. So the question is looking for, calculate the concentration. So this is what we're looking for. We have the mass and we have the volume. So using this equation on top, we can therefore work out, so we're looking for concentration. And on top, we have mass, don't we? So we have 8 grams divided by 2 decimeters cubed, which gives us a concentration of 4 grams per decimeter cubed. And that's our answer. Now let's have a look at volume units. As I was saying earlier, that we have to use decimeters cubed. Now, one good thing to remember is that 1000 centimeters cubed is equal to 1 decimeter cubed. Okay? So what do we do? So for example, here we divide by 1,000. Now if we have decimeters cubed, so for example 10 decimeters cubed, and we want to find out the centimeters cubed, what do? We times by 1,000, which is 10,000 centimeters cubed. Now for example 250 centimeters cubed, and we want to find out decimeters. So what do? Once again, divide by 1,000. And once we divide 250 by 1,000, that leaves with 0.25 decimeters cubed. It's often the easiest to convert from centimeters to decimeters cubed before continuing with a concentration calculation. So this is the first thing we do when we see a concentration calculation. We want to see what the units are. If they're in centimeters cubed, we want to get rid of that and we want to have decimeters cubed. So let's have a look at a question. Question is 100 centimeter cubed of dilute hydrochloric acid contains 0.5 grams of dissolved hydrogen chloride. Okay, we want to calculate the concentration of the acid in grams per decimeter cubed. Okay, so what do we need to calculate? We want to calculate the concentration. So the volume of the acid will be equal to 100 centimeter cubed divided by 1,000, which equals 0.1 decimeter cubed. So here we have the conversion done. So we have the volume. So now let's look at the equation. So concentration of acid will equal to, so mass 0.5 G divided by the volume, which is 0.1 decimeter cubed, which gives us a concentration of 5 grams per decimeter cubed. Okay, now moving on, let's have a look how to calculate the mass of a solute. So in order to calculate the mass of a solute, we use the same equation. So the equation, as we were looking at before, concentration equals mass divided by volume. We want to now calculate the mass. So what we have to do is we have to rearrange the equation for the concentration that allows the mass of a solute to be calculated. So mass of solute. Also, what I find easy is using triangles. Okay, so you've got mass, concentration, volume. Okay, cover one, and it tells you what to do. So for example, if we cover mass, that means that it's concentration times by volume. Once again, units, grams, concentration is grams per decimeter cubed, volume, decimeter cubed. Okay, so let's have a look at an example question. And the question is, a solution of sodium chloride has a concentration of 10 grams per decimeter cubed. What mass of sodium chloride is dissolved in 2 decimeter cubed of solution? So what do we know? So we know the solution of a sodium chloride has a concentration of 10 grams per decimeter cubed. So we know the concentration. We want to work out the mass, but we know the volume of the solution, which is 2 decimeter cubed. Okay, so using the top equation, mass equals concentration times by volume, we do mass equals concentration 10 grams per decimeter cubed times by 2 decimeter cubed, which is equal to 20 grams. Okay, and that is our answer to the mass. One final bit, and this only applies for higher tier. So let me just make a note over here. Higher. Okay, the concentration can be increased by dissolving more solute in a given volume of solution. Okay, so concentration can be increased by dissolving more solute in a given volume of solution. And this will increase the mass of solution because we'll be dissolving more things in this solution, and therefore the mass will increase. Now, what is another way the concentration of a solution can be changed? Okay, the concentration can be increased by allowing some of the solvent to evaporate, and this will decrease the volume of solution. Okay, so there's two main ways of changing the concentration in a solution. So one way is by adding more solute into the solution, which will naturally increase the mass of solution, okay, as we can see here. And the second way the concentration can be increased by allowing some of the solvent to evaporate. By this we are losing the solvent, and therefore the volume of the solution will decrease. Okay, that is all for looking at the concentrations of solutions.